Hey, welcome back to algebra class. It's good to see you, or in this case, not see you, but speak with you via video lesson. Okay, anyways, you get what I'm saying. We are in Unit 4. This is Lesson 7. Now that means we actually skipped over Lesson 6, and I'm going to go ahead and say you're welcome for that. Lesson 6 is all about setting up different kinds of linear equations to represent word problems. In this environment of learning, it would just be too difficult to try to really teach that effectively, and it's not crucial. So we're going to go ahead and skip on to Lesson 7, learning about parallel and perpendicular lines. And you're probably thinking, oh my gosh, I already know what parallel lines are and perpendicular lines are. Well, that's great, but that's not what this lesson is about. It's not just about parallel and perpendicular lines. It's about the equations for parallel lines and the equations for perpendicular lines. So I'm going to teach you a couple things that you can do with linear equations to determine if you're looking at parallel lines or if you're looking at perpendicular lines. So it's not as simple as you might think. Although that being said, it also is not hard. It really isn't. This is day 1. So again, it's going to be a multi-day lesson. So we start off, what are the definitions for parallel and perpendicular lines? Granted, you already know this, but that's okay. It doesn't hurt to review. Parallel lines, as you can see here, Mr. Potato Head's walking on some parallel lines. These are lines that never intersect. This would be nice to have in your notebook, by the way. As you can see here, these two lines are parallel to each other. They could go on and on to the right and on to the left, and they will never, ever, ever touch one another. They'll never crisscross. They will never intersect. Algebraically, that's what that says. Algebraically, how do we know if two lines are parallel? Okay, well, in other words, if you are looking at the linear equation for this line and the linear equation for this line, and you're not actually seeing the lines, but you're just looking at the equations, how can you tell if they're parallel or not? Check this out. Parallel lines have the same slope. So if you're looking at two linear equations and you notice that they have the exact same slope, you are looking at equations of parallel lines. For example, y equals 2x plus 1, the slope is 2. And y equals 2x minus 7, the slope is 2. So because these lines have the exact same rise and run, or the exact same driving directions, or the exact same slope, you know these lines are going to be parallel. What's different is their y-intercept. This one would cross through the y-axis at a positive 1. This one would cross through the y-axis at a negative 7. Now, real quick, let me just jot that out so you can see what I mean. You have to bear with me. Imagine that that is a coordinate plane. And the first one, a y-intercept of positive 1 would be like here. And slope of 2, I don't know, let's say it's something like that. And the next one has a y-intercept of negative 7, so somewhere way down here. Same slope, which means it's at the same like rise and run, or the same angle, if you will. Like that. That makes those parallel lines with the same slope and different y-intercepts. So it's as simple as looking at the slopes, you guys. Now, perpendicular lines, a little bit different. Perpendicular lines are these two lines here. I don't know who that character's supposed to be. I can't really tell. I didn't create this graphic. But perpendicular lines are lines that intersect or cross each other and form a 90-degree angle. So, lines that intersect at a 90-degree angle. They make that sharp little corner right there, and there's that little box that indicates a 90-degree angle. Now, if you're looking at equations for these lines, and you don't actually get to see the lines, what are we looking for? Again, we're looking at the slopes, but it's not that they have the same slope. Their slopes are, well, let me just write it out. They have negative, which means opposite. One's positive, one's negative, like plus, minus. Reciprocal, which means flipping fractions over. Slopes. So they have negative reciprocal slopes. That means one will be positive, one will be negative, one will be like the fraction 3/4, and the other will be the fraction 4/3. Check this out. Y equals 2x plus 1, right? Now, what's the reciprocal of 2? Well, it'd be 1 over 2, right? Because this is really 2 over 1. And this one's positive, which means this one has to be negative. And they can have different intercepts, of course. That's fine as well. But it's really all about the slopes. So again, we want to focus on the slopes of the equations. And this one is a positive 2, or 2 over 1. And if you flip it over and change it from positive to negative, and this is a situation you have, then you are looking at perpendicular lines. Opposite reciprocals, or negative reciprocal slopes. Okay? Now, what are negative reciprocals? Okay, so let's practice this concept first. What is the negative reciprocal of 3/4? Well, reciprocal means flip it over, and if it's currently positive, make it negative. So negative 4/3. Let's remember that when you're writing a negative fraction, I don't care if you assign the negative to the numerator. I don't care if you instead give it down here to the denominator, or if you just write it out to the left-hand side. As long as there's just one negative somewhere in this fraction, you're good to go. One negative sign. Numerator, denominator, or out to the left, I don't care. Okay? What is the negative reciprocal of 2? Well, that would be negative 1/2, right? Because 2 is 2 over 1. Negative reciprocal of negative 7/8, well, the negative of negative is positive. And you flip over 7/8 and you have positive 8/7. What's the negative reciprocal of 1 over 1? Negative 1 over 1. And the negative reciprocal of 0 over 1 is 1 over 0. And because the 0 is in the denominator, you can't leave it that way. That is undefined. Remember that? This would be a slope of 0, and this one would be undefined. This one would be this way, and this one would be this way. So if the 0 is in the numerator, it's a slope of 0. If the 0 ends up in the denominator, that's undefined, right? So I would expect to see the word undefined there. Okay. Determine if segments AB and CD are parallel, perpendicular, or neither. When they say segments, they basically just mean lines. So don't get all caught up in the whole segments A, B, and CD. These are just lines. If this line goes through these 2 points and this line goes through these 2 points, are they parallel, perpendicular, or neither? Well, we can't tell until we find their slopes, right? You have to calculate the slope of AB, you have to calculate the slope of CD, and then you have to compare them and see what the situation is. Are they parallel, perpendicular, or neither? So let's do it. Let's figure out the slope of AB. Slope is M of line AB. That's what that means, slope of AB. Ready? Here I go. How do I get from a 3 to a 6? I go up 3. That's my top number. How do I get from a -2 to a +2? I go up 4. So the slope of AB is 3/4. Now I look for the slope of CD. And again, I'm kind of using that Glessner method for calculating slope. If you would rather set up subtraction problems for the y's and then subtraction problems for the x's, you could do it that way. I don't. Kids always mess up the subtracting with the negative, so I just don't do it. Okay, back to my way. CD. How do you get from a 0 to a 3? You would be going up 3. How do you get from a -1 to a 3? You would go up 4. So I have a slope of 3/4 and a slope of 3/4. Same slope, right? Same slope, parallel lines. Parallel. Same slope. Good. Let's do number 2. Let's find the slope of AB. From a 2 to a 4 is up 2. From a 0 to a 5 is up 5. That slope is 2/5. Now we'll find the slope of CD. From an 8 to a 3 is down 5. And from a 1 to a 3 is up 2. Now I just have to compare my slopes. I have a 2/5 and a -5/2. That's opposite, reciprocal. These are perpendicular. And you can just write perp. That's fine. I know what you mean. Cool, all right? It's not that bad, is it? Okay, let's do number 3. Slope of AB. From an 8 to a 6 is down 2. From a -1 to a 2 is up 3. And the slope of CD. From a 2 to a 3 is up 1. From a -1 to a +3 is up 4. Compare your slopes. There's no pattern here. It's not the same slope. It's not opposite reciprocal. So this is neither. So it can be parallel, perpendicular, or neither. Again, all you really have to do is calculate the slopes and then analyze them. Okay? It's not too bad. Well, guess what? I'm going to make it even easier for you. I'm going to give you some examples where they give you the equations, and basically that means they are giving you the slopes, if you know where they're hiding in the equation. Had to get a little drink there. Okay, the directions say, determine if the equations are parallel, perpendicular, or neither, and this time they give you the equations. So, can you find the slope here? Can you find the slope here? And then you just have to analyze the slopes. So, for the first one, the slope is 7. For this one, the slope is also 7. Remember, slope is always attached to the x. Y equals mx plus or minus b. M is your slope. It's always attached to the x. Slope is 7. Slope is 7. Same slope. Parallel. Easy, right? You don't even have to calculate anything, for goodness sakes. How about this one? The slope here is 4/5. And the slope here is -5/4. Opposite, reciprocal. These are perpendicular lines. Ridiculous, right? Good. How about here? This one. Slope -1/3. Here, slope +1/3. They are opposites, but they're not reciprocal. So this is neither. They're not parallel or perpendicular. Oh man, don't you know it? What have they done? That's standard form. That's not good. We need it in y equals mx plus b form. If your equations are not in y equals mx plus or minus b form, if they're not in slope-intercept form, you're going to have to do your magic and rearrange the equation. So let's do that. Let's rearrange this. We need to solve for y. So we need to subtract the x and then divide by 6. So I'll do it step by step. I'll subtract the x. And now everybody's going to get divided by 6. Okay? So on this one, my slope is negative 1/6. Now let's do this one. All right, I just need to divide everything by 3, right? In order to solve for y, everything's going to get divided by 3. So the slope on this one is 6, or 6/1. Now I compare my slopes. Negative 1/6, positive 6/1, those are opposite reciprocals. These are perpendicular lines. Right? So sometimes you're going to have to manipulate your equations. Let's do another one like that. This one's already done. That's nice. This one we can see y equals mx plus b. M is negative 1/5. We don't have to manipulate anything there. That's nice. This one we do, though. We have to solve for y. So minus 5x from both sides, and then divide by negative 1. So the slope on this one is 5/1. They are opposites. One's positive, one's negative, and they are reciprocal. So again, we have perpendicular lines here. Okay? So now they're asking you to dig way back in your brain and remember how to manipulate linear equations to get them in slope-intercept form so that you can easily identify the slopes. All right? The very last one I want to do, these are interesting. Let's think about these. Think about the line where y equals 6. What kind of a line is it where y equals 6? We've done these. We just haven't talked about them in a while. Well, really, what this one is, where y is 6, you could think of it as this. Right? 0x, 0 times x is 0, so it kind of went away. Y equals 6, that is a horizontal line. In other words, m is 0. And over here, the line where x is negative 1, where x is negative 1, you guys, that is a vertical line, right? It would pass through negative 1 like that, and it would go up and down like so. So that would be an undefined. So this could be like, a slope of 0 could be like 0/1, and undefined would be like 1/0. So guess what? These are perpendicular lines. They are opposite reciprocals, essentially. One is vertical and the other is horizontal, vertical and horizontal. So watch out for those. You really have to have a good understanding of horizontal lines and vertical lines in the equations for them in order to really understand what the slopes of those lines look like, and then to be able to analyze those to see that they are actually perpendicular lines. Okay? All right. Remember, this was just day 1. We actually have a little bit more to learn about this concept, but we'll take it, piece by piece. So be in touch as needed, and I'll see you in our next Google Meet. Okay, thank you.